So in homework 1.2, problem number 20, we're given a system with an h and a k, and we want to find out the values of h and k that will make an inconsistent system, a consistent system with a unique solution, and then a consistent system with infinitely many solutions. And we're going to read this through the augmented matrix. So no solutions in terms of the augmented matrix would mean that the augmented matrix has a pivot in the rightmost column. So that's what we're going to get for no solutions. There's going to be a pivot in the rightmost column. Pivot in the rightmost column of the augmented matrix. That's what's going to tell us that there is no solution. So we're going to read this by looking at the pivots, so we need to look at the augmented matrix. The first column of the augmented matrix will be 1, 2. The second column of the augmented matrix will be -3, h, and the third column of the augmented matrix will be 1 and k. So we try to get a pivot in the first row, first column, and we got one, and it's even a 1 for us. So hey, thank you, David C. Lay, for putting a nice 1 for a pivot there. I want to use that pivot to zero out the rest of the column. So to do that, I'm going to replace row 2 with -2 times row 1 plus row 2. So let me write down what -2 times row 1 looks like. That'll be -2 plus 6 and -2 again. So my first row is going to remain unchanged at 1, -3, 1. My second row will become -2 plus 2, which is 0, 6 plus h, or h plus 6, and then -2 plus k. So I'll write k minus 2. My first row remained unchanged. And I've got a pivot in this first column. So this is far enough. We don't have to go all the way down to try to get a reduced row echelon form, because that would require that we divide by h plus 6. And if h is equal to -6, then we can't divide by h plus 6. So that's just against the math rules. We can't be dividing by 0. The math cops will come and arrest us. So in part A, we want to have the augmented matrix of an inconsistent system. That means there's a pivot in the rightmost column. So in part A, there's going to be a pivot in the rightmost column. An inconsistent system means a pivot in the rightmost column of the augmented matrix. To read an inconsistent system, we would see a pivot in the rightmost column of the augmented matrix. That means that second row will look like 0, 0, not 0. So that row would look like 0, 0, not 0. That's what that second row should look like. To get a 0 in the second column of the second row, that means h must equal -6. So to make this happen, h has to equal -6 to make that 0. And to make the last column not 0, k can be anything but 2. So if h is -6 and k is something other than 2, then the last row will look like 0, 0, not 0. And that will give us an inconsistent system. Once again, this is an exercise in reading pivots. In part B, we want to have a consistent system with a unique solution, and that means no free variables. that means all the pivot column, that each column corresponding to a variable must be a pivot column. So let's look at what B has to have. So in B, we need a consistent system and a unique solution. So we need a consistent system with a unique solution. And this requires a couple of different things. To get a consistent system, we have to make sure that we do not have a pivot in the rightmost column of the augmented matrix. We do not have a pivot in the rightmost column. Of the augmented matrix. So to make a consistent system, we have to make sure we don't have a pivot in the rightmost column of the augmented matrix. A unique solution means we have no free variables. So no free variables. So each column of the coefficient matrix must be a pivot column. So each column of the coefficient matrix must have a pivot. So our augmented matrix, the second row of the augmented matrix, will have to look like 0 here. We want to make sure that we have each column of the coefficient matrix must have a pivot, so we have to make sure it's not 0 here. Once we have not 0 in the second column of the second row, then that's going to be a pivot. So the third column can be anything. So it doesn't matter if we get a 0 or a non-zero in this last column because we've already filled up that second row with a pivot. So not 0 just means that h is not equal to -6. If h is not -6, then we'll have a pivot in the second column of the second row, and we will have a unique solution because each column of the coefficient matrix will have a pivot. That is, each of the columns corresponding to a variable will be a pivot column. Since the last column can be anything, that means k can be any real number. And so these are the conditions that will give us a consistent system with a unique solution. Any questions? For the third part, part C, we want infinitely many solutions. So in part C, we want to find h and k so that we have infinitely many solutions. So it's a consistent system. And there's going to be many solutions. We want a consistent system with many solutions. A consistent system means that we don't have a pivot in the rightmost column of the augmented matrix. Make a consistent system, we have to make sure that we do not have a pivot in the rightmost column of the augmented matrix. If there are going to be many solutions, that means that we are definitely going to have a free variable. And because the column corresponding to x1 is a pivot column, that means x2 is going to have to be our free variable. So many solutions means there will be a free variable. Many solutions means that we have to have a free variable. That means since x1, the column corresponding to x1 is a pivot column, the column corresponding to x2 must not be a pivot column. So since the column corresponding to the variable x1 is already a pivot column, x2 is going to be our free variable. So that means our augmented matrix has to look like the second row will have to be a 0. And since I don't want to pivot here, this has to be 0. The second column of the second row must also be a 0 because I don't want to pivot there, so that x2 can be a free variable. But if there's a 0 here, we have to make sure that we have not 0 in the rightmost column. The first row is still 1, -3, 1. So x1, it must be a basic variable because the column corresponding to x1 is a pivot column. We want x2 to be a free variable so that there's a non-pivot column there. So to make this happen, to get a 0 in the second row, second column, that means that h must equal -6. And to make sure that we don't have 0 in the last column, k cannot be 2. So if h is, oh no, k must be equal to 2. I looked at the not 0 one and wait. If k is not 2, I need k to be equal to 2. You are correct. And I'm doing this backwards. There we go. Thank you. 1,000,000 points for Celia. I need a 0 there so that we don't have a pivot in that column. So to make that a 0, I need k to be equal to 2. That was a close one. Any questions? So once again, since I messed it up, I need to have, to make a consistent system, I need to make sure that there's not a pivot in the rightmost column of my augmented matrix. Since we want a free variable to make many solutions, x2 has to be the free variable since x1 is a basic variable. That means x2 does not have a pivot. We don't have a pivot in the column corresponding to x2, and that forces h to be equal to -6. That puts a 0 there. But since we want a consistent system, we don't want to pivot in the rightmost column of this augmented matrix, and that forces k to equal 2. The problem was I looked over at the numbers, and I just looked at what I wrote before and just wrote it again. Because the human brain is a terribly lazy place. Any questions? Every semester I assign this problem, and every semester someone asks about it because it's a perfect problem. It forces you to read all the pivots, and that's what the game is about. Finding enough echelon forms so you can read the pivots, and if I say write the general solution, that just means you have to write the reduced row echelon form. Any other questions in homework 1.2?
So for A,
Which
for
one?
that problem,
Yes.
You wrote that as not 0, correct?
For part A, to make
Yes.
an inconsistent system, I want this last column to be not 0, because that's the right. I want to pivot in the rightmost column of the augmented matrix. So yeah.
Okay. Right.
Because if k is not 2, then this second, and h is -6, then I get 0, 0, not 0. There's a pivot in the rightmost column of an augmented matrix, and that means an inconsistent system.
Okay.
How's everybody? A lot of students find linear algebra to be the first time we can't just like copy what happened in the example problems and then do that over and over again 1,000 times without even thinking about it. That's what makes it fun. Any other questions on homework 1.2?
Yeah. Can we go over one? I'm sorry. Can we go over 1 and 12?
So in problem 1, we want to determine which matrices are in reduced echelon form and which are only in echelon form. So the answer in some cases is neither. So in 1.2, part C, there's a row of zeros that's above a non-zero row. And so that's not in either echelon form or reduced echelon form. So part A, 1A is reduced echelon form. Each of the pivot columns contains a 1 and zeros everywhere else.
Okay.
1B is also reduced echelon form. In 1C, that's neither echelon form nor reduced echelon form, so it's neither. And then 1D is just echelon form because we don't have ones in our pivot positions. So it's just a matter of reading where the pivots are going to be.
Gotcha. Okay.
So in problem 12, we have an augmented matrix and we want to write the general solution. So that means getting ourselves to the reduced row echelon form. We could just start writing the equations and solving them, but why are we learning about all these row operations if we ain't going to use the row operations? So let's write down the matrix from problem 12. So the first column of this matrix, it's a 4 by 5. First column of this matrix is 1, 0, 0, 0. So that one's already done. The second column of this matrix is 0, 1, 0, 0. So that one's already done. The third column is -9, 3, 0, 0. Non-pivot column, that one's already done. The fourth column is 0, 0, 1, 0. So that column is done. And the fifth column is 4, -1, -7, 1. 4, -1, -7, 1. This is the augmented matrix of a linear system. So what do we observe about this augmented matrix of the linear system? That means we don't have to do any work on this matrix. What's inconsistent?
The fourth row.
The fourth row is not inconsistent. The fourth row is just a row. The last column is not inconsistent. It's just a column. The system is inconsistent because the augmented matrix is a pivot in its rightmost column. So we know there's a pivot in the first row, first column, second row, second column, no pivot in the third column, a pivot in the third row, fourth column, and a pivot in the fourth row, fifth column. So there's a pivot in the rightmost column of the augmented matrix. pivot in the rightmost column of the augmented matrix. Therefore, the system is inconsistent. Notice that it's the system that is inconsistent. It's not the matrix that is inconsistent. The matrix is just a rectangular array of numbers. It doesn't have a truth value. The system can be true or false. So that's what can be consistent or inconsistent. And we conclude that by looking at a pivot in the rightmost column of the augmented matrix. Note that the linear system also does not have a pivot in its rightmost column because it's just a system. It doesn't have columns, it doesn't have pivots. So it's two separate things.
Gotcha. Thank you.
Incidentally, since most of this is done, what is the reduced row echelon form going to be? What changes in the reduced row echelon form? Can anybody see it right away? If you're performing row operations, stop. We can get there with no row operations. The reduced row echelon form is just going to take this last pivot column, the fifth column, and use this one to zero out the rest of the column. Whatever row, the last row won't become zeros because I can't zero out this one. But if I use this one to get zeros above, that's not going to change any of the other entries in the rest of the matrix. So if I want the reduced row echelon form, since there's only one column to go, I do some row operations and I just zero these out. So the reduced row echelon form is easy to find because doing a pivot on this one to zero out the rest of this column won't have any effect on the rest of the matrix. So the last row we can't turn into zeros, but the last column is easy to zero out because it'll have no effect. Those row operations will have no effect on the rest of the matrix. DVD bonus material right there, note. Using the one in the fifth column, one, two, three, four, five. Yeah, using the one in the fifth column to zero out the rest of the column, will not change any of the rest of the entries because there's zeros in the rest of it. It's good to make observations. It's good to make observations like that as we go. We don't just want to see the one thing that we've been asked about. We want to see everything that we can see. Any other questions in homework 1.2? All right, let's stop the video there.